Okay, I want to talk about roots a little bit more, not just square roots anymore, but cube root, fourth root, fifth root. And the first thing I want to talk about is this fact that sometimes roots don't cancel. So when do they cancel and when don't they cancel? Well, let's say I have -3 and I square it and square root it. -3 squared is 9. It's -3 times -3, and square root of 9 is 3. So it doesn't cancel anytime you have an even power and a negative number inside. So if you're trying to square and then square root a negative number, you don't get the original number back. You actually get the number back without the sign, which we all know is the absolute value. Now, I haven't proved that. I've just demonstrated why it seems plausible that when you square a negative and square root it, you get a positive. I haven't proved that squaring and square rooting gives you the absolute value. Let's do the same thing for -3 to the fourth, and I will take the fourth root of it. So I have -3 times -3 times -3 times -3. Well, that's going to give me positive 81. And then fourth root of 81 is just positive 3. So once again, it looks like because I'm raising it to the fourth power and then fourth rooting it, the negative goes away. In general, anytime I have an even power and an even root like that, the negative goes away, and as you can see, the nth root of a to the nth is just absolute value of a. So if a, whatever number a is, if a is positive or negative, when you raise it to a positive power and then take that root of it, you get a positive number back. Now, let's see what happens if I am not square rooting anymore. Let's say I'm taking -3 and I want to cube it and then take the cube root. Well, in this situation, I have -3 times -3 times -3. That's going to give me -27. And cube root of -27, your calculators will actually do this for you, but cube root of -27 is -3. So if I have an odd power here, the negatives do cancel, or I should say the root and the power cancel, and you get the original number back. So when n is even, the sign goes away. You have absolute value of whatever you're trying to work with. If n is odd, the sign stays. Okay, let me do a couple more examples for you here, or a couple examples for you here, I should say. Let's do cube root of 8. Well, I need to find the number that when I multiply it by itself 2 more times, or 2 times, I get 8. And I think that number is going to be just 2. Or let's say I want to do fourth root of 1 over 16. Well, as we'll see, you can do the top and bottom separately. Fourth root of 1 is 1. Fourth root of 16 gives you 2, because 2 times 2 times 2 times 2 gives you 16. Last example, let's do fifth root of -32. Now, I know that you're probably not used to doing roots of negative numbers, but as long as it's an odd power, this is possible to do. You just have to think about a number that when I multiply by itself 4 more times, or 4 times, I get -32. Well, I think if I had -2 and I multiplied it by itself 4 times, I think I'd get -32, so my answer is just -2.